last talk for the dev room and for today. I think it fits very well with the previous one. It's about streaming, but different, like why did you use flow instead of state? So welcome, Ralph from Mobile.
So yeah, I'm Tarek. I'm working as a technical evangelist, so I'm helping for the adoption of Mapar technology, big data, Hadoop, and so on, with developer community and customer. And one of the discussion I had quite often is with real-time data. We saw the last two presentations, one on Flink and one before on with Geode about real-time data processing and ingestion. And a big discussion that I have with the developer and customer is about why and how do you move to this. And this one will be less technical than the previous one, so it's really about more how we came to streaming the data in. And if you look, myself, I'm coming from the Java EE background. I've been working as a developer and working on the Lucky Java EE container of Oracle as a developer. And we build very, very heavy applications in a one single kind of box, but multiple layers internally with a database, middleware, web tiers. And we had to build, to give some flexibility to moving to this. We try to kind of create multiple sub-applications that are now using this way. So you have many applications, each of one having the web, the middle, the database, and so on. And this is where the service-oriented architecture kind of pop up, and as infamous for the lucky one that work with that, with the ESBs. And one of the issues we had with the ESBs, it was very nice to kind of glue again the different applications together. But the big challenge we had is still you have some silos in terms of technology, in terms of data, and so on. And plugging the ESB into the architecture was an issue, mostly because of performance and scalability. And I will come back to the type of application we deal with today. And you can, based on the two last presentations that give some example, you will see the volume of data where ESB was not the proper answer. If you look at the various startups, and startups is probably not the good term, I should have said, Silicon Valley companies, is to compare with the companies that I'm working with on a daily basis, like more financial institutions, insurance, telco, and so on. Compared to this guy, what they have done is they move from this very large application, at least if you look at Netflix. Netflix before, when I used to live in California, I was a Netflix customer. But I was the old version of Netflix, receiving DVDs every 3 days by the mail. And what happened, it was managed with a large relational database, large applications. And some of the teams say we need to do a streaming as part of video streaming, not as part of data streaming. And they start to move a part of the application on Amazon. And this is how they build it. And they build a totally new architectures. And you can look at different technical articles about LinkedIn, Amazon, Google, and so on, saying they start with reorganizing the data with smaller applications and try to expose this data with an RPC, with a REST API, and so on, and using kind of very small components and move to a different application communicating either using RPC between them. So it's the application calling the other application, not the bus doing the job. And in reality, you cannot really continue with this approach of having a service calling another service all the time. It's better to have something that will work in terms of deferred processing, where you post something very quickly, and eventually you will consume it. Depending on many criteria, you will have to consume it later. And this is a very good use case for microservices. I don't know how much applications are starting to move to this architecture. We see more and more of this. People building a SWAT team for one specific service is doing it very well, but he has to expose and consume some data. The idea is to, if you look at this, and you stay on an RPC model, you will have a glue between the different services that will be to too sticky, why it's a loop. And what you want really to decouple that. And as part of this is the microservices is a great way of working, but you want to have more flexibility. So you want messaging between, or queues or stream of data between the different services. And in this case, you send a message from a specific application, somebody, one or multiple services will consume it. And one of the key parts to see around that is, first, it has to be asynchronous. It changes completely the way you deploy and develop the application. And why it has to be asynchronous? It's because first, the volume of data you will consume could be very huge, so you cannot control always the same latency on different services over the network and so on. But also, because if you, one of the services could be down. Microservices applications are very, very easy to develop. They are very complex to keep up on living and understanding what's happening. So by doing that asynchronously, when a service will emit an event, emit a message, for example, on different technologies like we talk about, Flink or Spark streaming and so on, you will consume the event on the other side when the service is up and running. If not, you will wait and you will consume it when it's coming back. And the volume of message you can deal with could be very, very large, but every time you will insert one in this, if you see the number of messages that are generated behind that, we have one message that we are at the top level, 1, 2, 3, 4 messages consumed or generated behind the scene. So the number of messages that you have to deal with in real time behind the scene is huge. So you need to have an infrastructure that can manage that properly. And as part of this is one of the reasons the traditional message queuing system that are transactional, saving too much data, waiting for acknowledgement from another part of the system won't scale. If you have millions of messages per second, and you want to have to wait to every message that has been received by every consumer that you want, it won't work. Especially if we look at something else, that is the state of the data that you have to manage. Somebody asked in the previous presentation about IoT, for example. If you want to have to deal with the state, what's the temperature in different places of the world? That does not exist. If you are in Belgium or in France, I'm from France, you can guess from my accent. If you want to know which temperature it is now in San Francisco or somewhere in Argentina, only with a network latency, with no problem, you won't be able to show that it's real time. And if you imagine to have sensors all over the world from many factories and you want to capture the temperature all the time, what you will accept, because it depends on the type of application you are building, but if the goal is to build and aggregate data from all over the place, all over the world, all the time, you want to stream the data. And you will deal with the fact that sometimes the network will not be available. Sometimes this data will take some time to get with it. But you want to be sure that the message comes eventually to your master backbone kind of your application. This changes a lot the way you want to build the application. So we are not talking about the state, because the state, when you take the picture, doesn't matter anymore. Suppose you have this node down, the network down, or you are working on ships, boats with container on it. You want to be able to get data when they will have a satellite connection, sending data to give you, this is where my boat is, this is the status of the engine, and so on. And think about a connected car. You will send message when you can using your 3G connections to the main data center. This is exactly the type of application where you see that working with stateful applications and waiting for a specific state will not work. Trying to get the data streamed in using a flow will help a lot in terms of architecture. You will have a completely different approach in terms of development. And I will take one example with a concrete application when we move from a very large application to a more microservices oriented with streams, and see some of the challenges or some of the benefits in the same time. So Imagine you are building a YouTube or an equivalent YouTube of an application. So you have to capture from your website, and we will just look at the green part. When you capture a video, you have to upload it. You have to extract metadata. You have to transcode it to a format that is your format optimized. And you have to extract many thumbnails. Like when you look at the video, it's very efficient. And obviously, many data will be stored in the database and will be stored inside the file system. A very common way of doing that is you do that asynchronously, but with a big service. Instead of that, many applications now, you explode that in many, many small services. Each time you have one thing to do, you create one service. For many reasons. Because you want to switch from a specific file system to another file system. You want to switch from your own file system to S3 because you want to push data on the cloud. You only have this part to change, like snapshot or video metadata and so on. And instead of, once again, calling directly a Java API, a Python API, and so on, you put messaging in the middle, message queues. And you do that in a way that has to scale. Suppose you have many messages. Once again, one message coming in, many messages coming down. So you need something that scales. And this is one of the reasons you have heard about Kafka, Apache Kafka, that give you this highly available, very scalable messaging capabilities, where your producer will push messages, and you will have people listening, or services listening for specific topics and consuming them. And one of the key parts for me in this, it's not only the scalability, it's what you have at the first part when I talk about the ESB. You have a lot of flexibility in the way you want to extend the architecture of your application. If you look at that, I just show you the information that are really business oriented. And you have many other services you want to expose to your application. And some of them will be, how do you deal with metrics? When you have the queue that is sending the message, you can use this message to populate data or do some work to have some metrics. Major exceptions, because sometimes you will have issues and you want to deal. You have specific queues that will be useful, or specific consumers that will be useful to do that. Checkpoint to be able to restart a specific process. Suppose when you do the submail extractions, you have 100 megabytes of videos to deal with. You have an issue. You know that at 56 megabytes you fail. So you don't have to do the full parsing of the file again. You can redo that. On all this, because you will be able to send messages and consume messages dynamically using your data flow. And this makes a big difference. And keep in mind that in the case of Kafka or MapperStream that use the Kafka API, the consumer doesn't just pull the broker. It's not something that the broker, the Kafka broker, will wait for anything. He will store the data. When somebody needs it, he gets it. So if you need more consumer, it will not have a big impact on the performance of the global application. Obviously, you will have detailed information about partitioning, so adding different brokers in a cluster, partitioning the data to distribute the read, distribute the write, and so on. But it has been made for that. And it's one of the reasons if you use traditional MQ solution, it's very hard to distribute, because when you deal with transaction to say, this guy have to read only one message, the message one time, I'll be sure that I alert all the brokers and the copies of the broker. This is why Kafka is just limited at least. So, in your application, focus on trying to get microservices architecture, and also start to use something that you will have a message queue that is very fast and very scalable. Look at Kafka. Globally, I will say look at Kafka. I say Kafka S because into Mapper we implement Kafka with a different storage based on the file system of Mapper. And you still have some part of your application where you have very large applications and very large services. You cannot rebuild everything. What will be important is to integrate that easily. Once again, taking messages or pushing messages. You will have many queues inside your system, many topics, many queues, and many storage. Somebody asked the questions about, can I switch my transaction from relational database to Flink? Yeah, sure, from the messaging, but from capturing and processing the data. You still have to store the data somewhere. Choose wisely where you have to put it at the end. Most of the solutions today will give you a capability to capture an event using CDC chunk capture, CDC in Postgres, or to capture an event, do whatever you want to, be sure that it's consumed at least by one consumer, and do something else and save it in another path. But you still have this, you need this highly scalable, available storage. This is all the big, I would say, NoSQL, big data infrastructure that will give you that out of the box. Before taking some questions, I will give you some 3 use cases I've been working on. Is very, very, very common use case, and this is why Kafka has been created. It's aggregating logs and manipulating logs. And suppose you are working in a very, very, very large company, and you want to monitor all your servers, all your devices. They will send log, you will capture the log using events. And you will do 2 things. Logs just to be able to capture them and do some analytics. Metrics to calculate some SLAs and be sure that you have your customer that is happy with the service you provide. You want to do that on many servers, capture that, aggregate quickly. You want to be able to do some information about, same in the healthcare industry, you want to be able to capture information from the patients, so I will say the customer, this is a good idea. The patients, information about medical record that will be stored in a given database, some information about the impact on specific medicine and drugs together with a specific illness. You will do some analytics, and you will always use, you write in one single queue, one single way, then you can consume and have as much service as you want. And you can push from a specific, for example, in this case, I am in a hospital in the US, that I will aggregate to an hospital that is in national, globally in the US, push some data into my main data center in Europe, and with all the information. Highly distributed, using messaging, you know that you will get that. The IoT one is a big, big part. For me, this is one of the stuff where we will have to deal with messaging all over, all time. Get message even quickly inside the system. And you will have different paths depending on, do you want to deal with the data in real time? Doing some alerts when you find a specific sensor or a specific value that is too high, or compare quickly using Flink, for example, with some calculations and processing to be able to alert that. You stream the data, you alert, you generate another event for a specific critical alert. At the same time, using the same topic, you will save the data in your main data lake to the analytics, to do all the work you want using SQL as before, also during the day. You can do SQL on any type of data. You store the data, you stream the data in real time, analyze and process them for specific real-time events. You save them on a different storage to do some long-term analytics or your machine learning model. So really a change inside the way you want to do your application. So I invite you to quickly, if you have not, look at Kafka. The API is quite simple and cool. See how it's integrated with a distributed processing layer like Flink. Because in this, you will have a very rich toolbox to create highly available distributed systems. Thank you. Questions?
How Kafka differs from traditional message broker?
So it's not transactional. So the fact that the way it saves the data, it's a more efficient way because Kafka just saves a log. So it will just append data and read in the same order in all the consumers. And because it's just a log that you internally, a log that happens, it's very easy to partition, it's very easy to distribute. In the same queue will be distributed on many nodes, but also you can duplicate in many other data centers. When you try to do that with traditional MQ like MQ series or MQs, try to do a multi-data center highly available cluster. It doesn't work very well, and when it works, usually you have a latency, long latency to get messages. But the important part is if your MQ today, whatever product you have, it's working perfectly as an asynchronous platform, you don't have to change. But what we see today is people are getting more and more messages. And one of the very common use cases is log aggregations, log transformation, and log processing. This traditional MQ, they cannot deal with the volume. Thank you.
One important thing before I thank you all and we close the bedroom. If you had a hard time coming in and you have to wait outside long, or if you just want to give feedback about the talks that you attended, under the description of every talk in the FOSDEM page, there is a link where you can provide feedback. And there is also a text box where you can write like very forceful, please give us a bigger one next year, something like that. Thank you so much.